So what is Kafka, right? So Kafka nowadays a very essential skill to learn, right? Especially if you know that in the modern day approach or modern day applications, we actually deals with a million, a billion of data, and that is also basically depends on couple of consumers, correct? So there, Kafka can actually play a very crucial role in terms of satisfying those needs, right? So specifically, as we are talking from the very basic level, so first we will just try to see what exactly the Kafka from the definition or technical description perspective, but I'm sure that that can create some confusions. So after that, we will actually try to come up with some real life examples, maybe the problem statement through which we can actually understand that what exactly the area where Kafka can help us. And gradually we try to get into the more information that what exactly the Kafka does and how can what type of problems that Kafka could resolve, right? But before that, let's get into the Kafka's official site. So we will come to this whiteboard later on. So first of all, if you see, this is kafka.apache.com. This is the official site, and if you open it, so you could see that technical terminology or technical description wise, what is Kafka is. So Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipeline streaming, analytics, data integration, and mission critical applications, right, folks? So these are like sounds very heavy words, isn't it? So we will try to cover each and everything, that why it is like what is like distributed and what is like event streaming and all those things. But just for an overall view, right? So if you see that in today's date, till today, that out of 10 manufacturing industries, 10 or out of 10 manufacturing industries where Kafka is being used. Similarly, for banks, the count is really like high. For insurance, also insurance domain-based companies, also Kafka is being used, and same for telecom industries, right? So if you see these counts, right? So what exactly does it mean? It basically means that how important to know about Kafka, right? In the today's world as part of the software development, right? So let's get into the whiteboard, which we already opened previously. So here I just prepared one very like basic type of example so that we can actually get into more details that where the Kafka can help us. And that's the reason first we need to know is why Kafka. That means like what exactly the problem this Kafka is actually addressing and why we should learn or we should use it. So let's take a very basic example, folks, right? So first, you know, right? Well, now it is. Let's say this is an online cab service, and as like this is very common nowadays, right? Each one of us, or most of us, at least one at a time, right? We may like use the online cab services nowadays. There are online bike services also, but both are like cab and bikes. That is also kind of a bike taxi, so those are like kind of work on a similar type of principle. So what is exactly happens? So for the time being, just forget about the technical things and all those things. If you try to think from the very basics, right, from the a normal consumer perspective. So once there is a online cab service, and we may have some kind of a application, that mobile application. So if I just write like mobile app maybe, and what exactly the user does through this mobile app. So user basically try to look for some cabs, right? They open it, and what exactly the online cab service does is, so first it will search for the available cabs, right? If I just try to highlight it, so first is try to maybe this color, yeah. So first is try to locate the driver or the nearby available cabs. So once the driver is basically confirmed your cab request, then there is an option called or there is a feature called, I could say, like location tracking, right? Which is very a good feature, I would say, right? So we can actually determine, like, or we can actually see where my cab is right now, right? So it's kind of a real-time location information along with the timings we are getting into our app. And similarly, once maybe our ride is ended up, the fare calculation also happens, right? So if you see that, these are the features, right? And these things from a normal, like, consumer perspective, we already aware of, isn't it? Now slowly come to the engineering part of it, right? So let's say we wanted to develop this kind of a service, correct? Then what could be our approach with the current mindset, right? So current mindset, we don't know about the Kafka and all. So what could be the solution, or what could be the approach that we can follow to develop this kind of a setup? So what we can do is, maybe these are the services that we have, right? These are the services, these are the multiple services we have. And what we can do is, probably we need to upload this information into some database, isn't it? Into some database, and this database may be hosted in some server. Why we need to we need to upload this information to database? Because obviously, in terms of producing this information to our consumers, we need the details, right? Let's say consumers, maybe you can, for the time being, we can consider that one of the user, maybe for the time being I'm considering only one user at my platform, and that user is actually using some mobile device. And this information I need to, whatever my cab is basically generating, right? This information I need to provide to my consumer. The another consumer can be, maybe this is another consumer, and this consumer, maybe the analytics. And it is nowadays very popular, as we know, right? Like, we need to generate the trends of our cab, or maybe to advertise the people, right? Or maybe see other services, to provide the other type of service. Analytics is very much important. So not only, so this is one of the consumers where our end user are getting the information, and there could be another consumer where we would like to produce the information, could be our this analytics service, right? So far this is clear. Now let's try to get into our more complexity, right? So let's say I have one more, or maybe few more consumers now, okay? And each and every consumers, they wanted to get the cab information, right? Right, that's what happens in the real life scenario, right? So let's say probably my online cab service getting popular, it got popularities, and I am planning to scale up my business. So what could happen, like, now I need to extend it, right? So now I need to extend it. So initially it was only one state, and now it is like been expanded, maybe 10 more states. So in the 10 more states, maybe each state, probably I have around 1000 or 1k or 1000 of cabs operationable, operating on cabs are there. And 1000, that multiplied by 10, so 1000 multiplied by 10. So these many cabs producing data. Sounds a bit interesting now. So initially what we have seen, that we have developed one application which are kind of looks like this, very basic architecture or like solution, and we are trying to hit the database each and every time to getting the details, and gradually we are good with that. But once my business has been scaled up, maybe it's expanded into 10 more states, and each state's having 1000 of cabs, right? 1000 of cab and cab drivers, and so many of users, consumers of it. So 1000 into 10, these many cabs are producing the data. Now just think from that perspective, like, how much data I need to handle, right? So for our understanding perspective, if I wanted to make it more simpler, let's not target maybe three features that whatever we're talking about. Let's at least take one of the service and try to find out, at least to manage one of the service with this approach, what could be the complexity we could have, or what could be the issue that we could found. The feature that I'm targeting to explain is location tracking, right? So what the location tracking, what exactly happening in the location tracking part? So let's say I'm like, this is my one point, like point A, and this is my another point, which is like point B. Okay, so I can consider like this is the maybe me as an like as an rider, and this is the cab, right? This is the cab along with driver, right? So I sent a book request. My online cab service is actually okay, fine. Okay, this is where the cab is available, maybe nearby me. And now this driver already accepted my request. The normal flow goes on. So what could happen now? So once the cab started from this location, so it is like the path is like this. Okay, the path is like this. So this is the path that the cab should follow to reach to my location, my current location. And now from the cab location tracking perspective, we know that from each and every location we are actually can get the real-time information about the cab. So these are the like dot points I'm just highlighting just to provide the location timing. So let's say my first cab probably started from here at 10 a.m. morning, and it's like keep on getting, like maybe this is 10 a.m. and maybe this is at 10:20 a.m. This is the location the cab was there. Maybe here cab reached around 10:30 a.m. 10:30, sorry, 10:30 a.m. and finally so many, so I'm just keeping the other timestamps, and finally it could reach me around 11 a.m., right? So if you try to open the respective app, so I just have provided maybe 10 minutes or 10 minutes delay here in the example, but it is like more real time, right? You can also track maybe second by second where your cab is actually there, the specific location. Now let's say I wanted to upload this information into my database. So let's say I'm considering this is my DB, and here whatever the table, maybe the location table I am having, location table, and this in this location table I wanted to save the location. One information is location and another information is time. So now think from that perspective, maybe I wanted to save the first data, maybe location 1 or location A, along with the time is like 10 a.m., right? Similarly, if I just wanted to save the another location, so I again maybe the location is same, location A, and maybe 10:01 a.m. and so on. So now you can see that maybe the timings are like keep on increasing based on the seconds now, isn't it, right? So if I keep on wanted to add the location information to this specific DB on a every second basis, so what could happen, right? There is a high chance my DB can slows down or maybe get into the crash, right? Why? Now the question is why? Because there is a concept called throughput. Okay, and for db it is low. Okay, so for database the throughput is low. What is a throughput? So throughput you can consider from that perspective that per unit time, whatever the data we can actually get right or maybe access from the database, that is called throughput, right? So for the case of database, the throughput is very low. That is the reason, if we wanted to capture this kind of real-time information, folks, this is a very important term, real-time information, right? And we just wanted to capture, or we just wanted to handle this entire real-time information with the database, it's going to be very difficult and problematic, and sometimes and obviously it could happen like in one time your database may not respond. That means what, your entire app going to be like crash, there is no use. Because this location tracking for the time being, maybe we just for an example perspective, we consider maybe one user at a time. What could happen, like there are, we said, like 10 state, 1,000 cabs, maybe 1,000, maybe millions of users, they wanted to get their respective location details or cab or driver information in the same time, in the real time as well. It is not like after 10 minutes my cab reached to me and then I'm sending the location information of 10:30 a.m. that where my cab is currently. So that is not the visible feasible case, right? So here, to solve this throughput or this huge requirement of real-time information, Kafka comes to the picture. Kafka comes to the picture. So now if you just try to tell me, right, from this discussion, one of the factor that we could understand that for low throughput, this type of scenarios handling is very much difficult. That means Kafka is having high throughput. Okay, Kafka is having high throughput, right? So that's the reason, like if we try to introduce a Kafka instance over here and then try to write our specific information or put our specific information into the DB, the things going to be very smooth and also real time. Now here is one question, then why we still relying on the database, right? Database in the sense like SQL database maybe, or PostgreSQL, anything. Then why we still like depends or relying on the database? Why we still consider a database for our development? Why don't we just simply replace the database along with Kafka, right? Then our whole problem solves, right? But we cannot do it. Why? Because the Kafka, the each and everything, right? They have their own like pros and cons. From this discussion, we got to know that database is having low throughput where Kafka is having high throughput. But from the storage perspective, database having the high storage capability where Kafka is also having the storage capability, but that is like kind of a temporary, right? And compared to database, it is low. But we know, right, to handle or the data and to store perspective and to be available with the system, we need a solution where we can make or we can store the data for a long time. That is the reason we cannot just remove the factor of database from our development or architectural plan, right? So we need both of the things. So we need database, we need as well as we need the Kafka. Make sense? So similarly, with this like relative problem, we can also take, or we can also discuss one more like real life example, that is like e-commerce platform. We all are using it nowadays, very common. So I'm just taking maybe 2-3 features out of it. So let's say there is a mobile item. So I can say that mobile phone. This is one of the product that is being available in some online e-commerce platform. So for the understanding perspective, I'm writing like e-com platform. Okay, so in the e-com platform, one mobile phone is available and I'm just planning to purchase it. So what would happen? if you see one mobile phone, right? So from the very standard point of view, what are the details that we can see on the mobile phone? So mobile phone can have, like, so I'm just writing as well. So let's say this mobile code is having this type of informations. So at least two three information we can actually gather for our understanding perspective. So let's say this mobile phone is having a unique product code, something like this. This mobile phone is having the price information, right? Price info. And this mobile phone is also having the quantity info, right? Because there is an option, right? Like how many, what is the count that you would like to place the order. It can be one mobile phone or multiple, more than one mobile phones, right? So these are the information, very basic three information for the time being we are considering that we can have from a mobile phone service. Let's say I'm considering from the technical perspective that mobile phone, which is nothing but an item. Maybe item is one of the service that we have, and this service is having this many details: product code, price information, quantity information. Makes sense? And so now again go back to the your normal thought process, where we already just assuming that we are on some online platform, and then e-commerce platform, and then we are trying to order one mobile phone. So initial from our usual behavior, what we are exactly doing there. So once we finalize that this is the mobile phone we need to purchase, first what we are doing is we are clicking on the add to cart button, right? And then initially, like usually, the browser or this application take us to the checkout page. So I'm taking one specific section and mentioning it here, like cart and checkout. So I can say that this is one of the service that we need to perform. That this is the one of this I can, like, this is the one of the service which can help us to proceed ahead. So once my cart and checkout done, what is the next step that is coming? Payment service, the payment part. So I can say that payment is another service. And let's say my payment is done. So after that, my order is being placed. And after, like, placing the order, what exactly we are seeing is like, where is my order now? Like, we can track the order. Sometimes we can cancel the order, isn't it? So the to address those kind of things, we may have one another service or one more service called order service, right? So now again, from the engineering perspective, if you think, so this is one of the item service which is being producing this type of information, like product code, price information, and quantity information we are getting from out of here. And these are the dependent services which requires this information. Cart and checkout requires maybe product code and price and quantity, these three informations. So these three information, this cart and checkout may require, right, these three information, and similarly for others as well, right? And similarly for others as well, this three information required. Similarly, payment service also required this three information to calculate the actual price or what exactly user need to pay for it. And order service also required maybe the product code only to track the order. Okay. And here also we can actually use Kafka as a solution. And moreover, this is something called, like, if you think from the perspective like microservice architecture, right? Because if you see that each and every things we actually said like a small services, and in the microservice architecture, like all, like, couple of small services can be integrated to each other, and finally uh, can support to a large system, right? So e-commerce platform is not a like small system, it's a huge platform, isn't it? So here also, where item service, if I say that item service is one of the section for the time being, I'm just targeting, or I'm just saying those things as a sections or service, but gradually we will also learn about couple of terminology which is associated with the Kafka. So this is one of the service which is being producing couple of, I can say, like data or information for the time being, and that data and those data, on those data these other services are dependent, right? And this data has to be real time, right? Because you are on the e-commerce platform, so like you or like me, there are like millions of people who are targeting to purchase the mobile phone, the same mobile phone, maybe some big billion day or this kind of days are running on, where most of the time like discounts are there, right? So the traffic is huge, so there are so many people around the globe, they wanted to purchase this mobile. And that is also real time, because if that is not a real time, then your cart and checkout may fail, your payment may fail, your order tracking may fail, right? So again, the use case kind of a similar, just like your online cab service, only the way that how it is doing, that is different, but still it is also required a real-time information. And we can also think of a solution like Kafka to be introduced here to manage the real-time information and produce and the data, and then manage the data, and finally provide the respective data to the respective service containers. Okay. So, and similarly, probably after watching these specific examples, you can also think of couple of more examples where you can actually introduce Kafka by your own. We discussed here two examples. One is online cab service, and second one is the e-commerce platform. Maybe something like that you can also think of, so that understanding going to be very clear, right? Just like the food delivery apps, right? Nowadays it is also using the same type of concept, where real-time information has to be produced and be consumed. Okay. So I hope with these discussions our thought process now at least improved a bit, and we at least get to know that what exactly the problem, or what is the area where we should go ahead with the solution called Kafka, right? Okay. So yeah, so that's it for this discussion. Later on we will see that from the Kafka perspective, what are the components and what are the implementation of Kafka